Runar. Please, the floor is yours.
Okay, thank you so much. So, welcome everyone to this webinar arranged by the 4Front cluster of projects about developing traffic and network management of the future. Just some rules for the webinar. I ask you to keep your microphone muted when you are not speaking, so we avoid any spurious noise in this webinar. And the question and answer session will be at the end, so please write down your questions during the presentations. And as Jenny already said, this webinar will be recorded. This is the agenda for today. I will have a short introduction to the 4Front cluster of projects. Then we are happy to have a keynote speak from Nico Stieldorf from Swarco. And then Leire Serrano will present data processing techniques for traffic management optimization, followed by Marit Natvik to present resilient orchestration of the traffic in the whole traffic system. And then Sasha Hugendorn Lancer will present swarm intelligence to manage traffic and mobility. And the final presentation will be by Panos Georgakis, stakeholder requirements and needs for future network management systems. And as I said, we will end the session with a question and answer part. First, some word about 4Front. This is a cluster of 4 Horizon 2020 funded projects. They all answer to the same Horizon 2020 topic, MG211, Network and Traffic Management for Future Mobility. This was a research and innovation action. The final deadline was September 8 in 2020. And all the 4 projects started during last year, during 2021. And the 4 projects are Tangent, Orchestra, Tit for Tram, and Frontier. And the purpose with this cluster is to collaborate to examine the future of network and traffic management. How this will shape cities, sorry about the spelling mistake, how to tackle new technological, societal, operational, business and governance challenges, and also for sure explore new opportunities, both based on new technology, but also based on new societal drivers. And relevant topics for this collaboration is architecture, resilience, trustworthiness, data sharing, governance, user behavior and acceptance, multimodality, and upscaling. So this is the first open collaboration webinar for this cluster of projects. Next collaboration will be joint communication and dissemination activities at the Connecting Europe Days in Lyon. So then I am happy to give the floor to Nico Stieldorf, our keynote speaker. So please steal the screen from me.
Here we go. Thank you very much for the handover. Can you guys all hear me well?
Yeah, we can hear you well.
Perfect. All righty. So pleasure to virtually meet all of you, and thank you. Let's actually remove me from that screen here. Here we go. Thank you very much for the invitation. Pleasure to be here. I'm going to talk with you and hopefully, or to you and hopefully with you guys about the topic of digital transformation on the journey of traffic management and network management. So quickly to myself, my name is Nico Stieldorf. I am responsible for the commercial side of our software platform business for Swarco. Swarco is, who does know the company, one of the globally largest ITS providers, and from a technology provider, privately owned company. So as a quick heads up before I start talking, we have really tried to make customer centricity our core differentiator. So that means we have so far conducted 453, I just took that snapshot yesterday from our dashboard, 453 questionnaires where we really go to different stakeholders like traffic engineers, cities, consultants, decision makers, policymakers, and ask things like, what are your top 5 problem statements? What new technologies do you see derive? What, for example, also, are you willing to use cloud systems? Are you willing to use subscriptional systems? Things like that that could really guide us and make sure that what we build are tools that solve the most critical customer challenges in the world of urban mobility management. So based on all these findings, what we then build out is a software platform called My City. And that is, without making this a product pitch, pretty much the platform that I'm commercially responsible for. And we use all this data to adjust the roadmap, to segment markets, and to really get into an iterative, let's say, design thinking style of process with our customer business, saying, is what we build really the most attractive thing right now to your needs? We have a big bunch of solutions within this platform, so from air quality monitoring to traffic management to different CCAM or CITS or V2X use cases to parking use cases to sign management. Yeah, but now I'm actually going to jump to I have three topics that I would like to address. Sorry for the presentation issue here, but newly emerging challenges on the path to becoming a smart city. And pretty much behind each one of these topics, I'll throw a hypothesis in the room that could be, or I hope sparks some thinking or discussions also. And questions, please shoot in the chat. If they're real fast to answer, I'll do it here. Or otherwise, like Runa mentioned before, we'll do that in the end in the Q&A session. So number one, lacking interoperability of systems. So something that we constantly heard in that questionnaire was that cities say, we're in a vendor lock-in. We talk about smart city, we talk about connected city, but our systems are not operating with each other. And once I have a system, I pretty much have more or less some handcuffs on and I'm locked in. So this was one of the big needs. Number two, we keep talking about CCAM or again, so connected collaborative autonomous mobility or V2X or CITS. So pretty much where all the different means of mobility become IoT devices, communicating devices, and therefore derive certain use cases. But really, if we're honest, that path is still very, very unclear. So, for example, when we talk about CCAM, it's not even clear what communication standards we're going to use and so on and so forth. So this was another big challenge that they brought up and said, we really have no clue which direction this is going. And lastly, cities can't cope with today's speed of disruptive innovation. And what many of the cities told us was, example number one, Uber happened, or let's say Maas started to happen. And they say, all of a sudden, my airport has 30% less revenue, parking revenues, which is their second biggest revenue stream in the airport. They have no clue how to make up. But then even those e-scooters happened, and then we had no clue how to handle it. And they pretty much say, with the systems that we currently buy, from central systems to hardware and so on and so forth, we really in our processes, but also in the dynamics of our products, we can't cope with the disruption or with the speed that today's disruption is happening. So based on these three findings, I'll throw the hypothesis in the room. The top requirement, and that's specifically for EU cities, is the procurement of dynamically evolving and open systems. The time of customized solutions, which was quite common, that you get something completely tweaked and customized for your city with a static set of functionalities, is over. So that would be the first one that I throw in the room, because this is something this is a way how our industry has been working for decades. Then number two, the role of SaaS and cloud. Actually, let me open it. So software as a service and cloud. First of all, large initial investments halt digital transformation. So when you want to implement large-scale new traffic and network management systems, for example, a lot of times this requires a hefty sum that usually excludes, if we're honest, specifically if you look at EU or European urban landscape, this excludes 90% of our urban landscape. They might not have these funds available. Then number two, cities face hurdles to consume the wide variety of recurring pricing models. So something that they told us, which we really didn't have on our radar at all, they say that one company now wants X amount of cents per gigabyte, the other company wants €1 per API call, the other one wants Y amount per month, and the other ones wants the amount per users that are on that platform. And we, the city, or we as a public entity, are not willing and flexible enough in our processes to handle all these different pricing models. And then lastly, access from anywhere via any device is becoming the norm. So on the one hand, we, but specifically cities, are facing that war for talent. It had been hard for cities to find good talent, and now even more specifically in an IT landscape to find talent. And when we talk about finding new talent, then that means probably no one these days would sign a contract that says you have to come 5 days a week to the office, and maybe you even have to be -1 floor, sit in your traffic management center and operate from there. So that was one topic. And then also when, of course, in our questionnaire, we could check the timelines, once COVID hit, it became even more critical. We had cities that said we simply cannot put enough staff because of regulations into our office. So all of a sudden they say, hey, our systems need to be on the one hand secure, but on the other hand, open enough so that we can have all these new use cases of sharing and receiving data, and giving people and our employees access from anywhere. So second hypothesis I throw in the room here is specifically small and medium-sized municipalities will not be able to reap the benefits of modern traffic and network management without the adoption of cloud and SaaS. That we're deeply convinced about. And then the third one, and here I wanted to show you 2 screenshots. So the first one is, for example, Carinthia. Some of you might know that it's a province or a state, one of the 9 states in Austria. That complete state right now, as we speak, is completely paralyzed. The IT system has been compromised and is down. Number 2, I didn't find an English-speaking snapshot for it. The court in Berlin was hacked, was paralyzed, but now they cannot find talent to fill in their IT security positions. So while they've been hacked, they contracted some external companies, but they cannot build structure to actually make it more secure. This is the current reality of our government entities. We have a bunch of customers, specifically in Hungary and Poland, that now during the Ukraine war simply pulled the plug on their systems, specifically on tunnels and freeway systems, because they say we are not capable of handling the IT security threats. And of course, pulling the plug is a short-term answer to this, but cannot be a long-term answer when we want to move into a world of modern network and traffic management, where data exchange is the real lifeblood of such a world. So here, first of all, lack of skilled IT resources and budget. Cities state to us, and specifically when we talk about the 90%, so not the large-scale cities like the Parises, Romes, and Berlins of this world, but everything below, they lack having these people, they lack finding these people, and they don't have the budget finding these people. Number 2, they have insufficient IT infrastructure set up to guarantee uptime and enable seamless scaling. They still have their server rack with a couple of wires. And when I say data, it's of course a rather general statement, and everything I state here actually came from cities. It came from stakeholders. This is nothing coming from me. And lastly, they have now an increased tendency to outsource the risk of data handling and breaches, because they simply know, on the one hand, it's really a financial risk, right, for your ransomware or for your ransom that you have to pay. But more than anything, this is critical data. This is private data. This is to some extent also reputation. So the third and last hypothesis I throw in the room is opening up mobility management systems to enable high-scale data exchange will require cities to outsource their security operations to SaaS operators. Yeah, this was kind of it from my end, my little monologue here. Again, thank you very much for the invitation. I hope it sparked a couple of thoughts. Will spark a little bit of a discussion. I'm excited to hear the next keynotes from my dear colleagues and then be part in the Q&A session later on. Runa, then back to you, I guess.
Thank you so much, Nico. Perfectly on time also, so that's perfect. So I just give the stage to Leire Serrano, please.
Okay, thank you. Hi all. I will share the presentation. Yeah. Let me open it. It's here. Okay, I think that you can all see the presentation now.
Yes, but is it possible for you to make it in presentation mode?
It's a PDF. let me. I can open. Yeah.
Control L and then it's gonna be full screen.
Okay. Mm. Okay. Okay, yeah, I will open yeah the other one. No, yeah, now. And now it's in presentation mode.
No, unfortunately not. It's not in presentation mode.
No?
No, it's not. Sorry.
No. So I cannot put it, yeah, do it in presentation mode. I don't know why, but I can share the PDF. The presentation doesn't have any animation, so
Okay, please
yeah,
go on.
should be fine. Yeah, okay. Okay.
So what happens if you press Ctrl L when you have the
Full screen.
Okay, now can you see it?
we see your presentation? Please go on.
Okay, okay, thank you. Okay, so I'm Leire Serrano from the University of Deusto. We are based in Bilbao, in the Basque Country, in the north of Spain. I'm the coordinator of Tangent project, and now I will give an overview about the project. Okay. So this is the contents that I will follow, some brief facts and figures. I will go through the overall concept, partners, and also I will review the timeline and the milestones. Okay, so going through the facts and figures, Tangent was presented to the same topic as the other sister projects in the call of 2020 for Mobility for Growth, for Network and Traffic Management for Future Mobility. It has an overall budget of almost 5 million euros, a duration of 36 months, and the project started the 1st of September in the 2021 year and is managed by a FINEA agency from the European Commission. So now going through the overall concept, Tangent project aims to develop new tools for optimizing traffic management operations in order to balance demand and supply of transport in a dynamic way and also from a multimodal perspective. So basically, the system triggers data from very different sources. All the data are related to transport and traffic. This is the case, for example, of multimodal transport data, also data gathered from sensors from the infrastructure, as could be, for example, loops, cameras, traffic signals, also data from connected vehicles and floating data, and other contextual data that is relevant for traffic management. For example, weather data, also considering timings of the days or days of the week is very relevant for delivering different ITS services. All this data is gathered in order to process by different modules based basically on data processing techniques and also artificial intelligence, different types and methodologies. So the first module is the travel behavior modeling that is focused on studying the travel patterns of different transport users. These transport users are considered from an individual perspective for knowing which are the transport needs and also the motivations for taking one transport mode or one route or the other. After, we have another module that is traffic network prediction and simulation. Here we will work on different predictive models for forecasting demand and supply in different time horizons. Also, predictions of traffic peaks and traffic congestions will be done under this module. And here we will consider different factors, such as, for example, the season, time of the day, the distance of the trip, and so on. And finally, we have a module that is the transport network optimization that will deliver different actions for traffic management. Okay. For this, we will consider the information gathered on the previous modules, as it's the case of the travel behavior modeling, and also information from a prediction module. All these services will be delivered. Basically are directed to city administration and transport and traffic management operators. The visualization of these outputs will be done basically in 3 services that you can see in the diagram in the bottom side, that are the Enhanced Information Service for Multimodal Transport Management, the Real-Time Traffic Management Services, and the Transport Network Optimization for Transport Authorities. And now I will go through explaining each of the services, let's say the key outputs, okay? These 3 services will be tested in real environment and also simulating different scenarios, but basing on specific case studies with the cities that we have involved in the project. So now I will go presenting the first one, that is the Enhanced Information Service for Multimodal Transport Management. So this first service will be showed in the way of a dashboard, and also will be an API that will feed the rest of the other 2 services. So this service will provide an overview on the status of the different means of transport, regardless are for private use or collective, or public or private. So, for example, bikes, buses, private vehicles, trains. So the information that will be shown will be in real time and also predictive information. The real-time information will be for knowing which is the status of the network at that time. For example, information related if there is congestion or there is free flow, also average travel times, also if there are any incidents happening or delays in the network, it will be shown as well. And related to predictive information, it will show information time ahead. So, for example, is the case of traffic congestion or bottlenecks, and also if the system identifies a potential high demand in different transport services. So now, if we move to the next slide, here you can see how this service could look like. It would be shown based on visualized in a map. Very probably we would show with different colors the status of the network. Okay, for example, green color could be free flow, and red color like very high densities. And also there could be different indicators showing the information related to the network. Okay, and now I move to the next slide. Yeah, here. Well, now we move to the second service, that is the real-time traffic management services. Well, this service aims to support traffic managers on operational and also tactical level for traffic management on daily basis. Here there are two key functionalities. The first one is the smart network load balance, and the second one, the cooperative incident management. Well, basically, the first one is when there is an incident and doesn't require cooperation of different agents from the transport network, and the cooperative incident management when different actors need to intervene. So, for example, the first one, if there is let's say, a disruption on the bus public transport, and it can be solved only by acting the public bus transport operator. But for example, the cooperative incident management, you would need gathering insights from various actors on the transport network for solving the incidents and giving a response plan. So now continuing with the second service, but now moving to the first functionality, smart network load balance. Here, this functionality will deliver different response plans, and it will have the focus of the study on two aspects. The first one will be knowing the progress of the use of transport, depending, for example, on dynamic congestion pricing schemes, and the other one is proposing different traffic control measures in the circumstance of connected and autonomous vehicles. So here we can see an example for dynamic congestion pricing. Here we can go directly to the example. There is an incident. The system predicts an anomalous non-recurrent traffic congestion in the city center in the upcoming 2 hours. So the response plan will provide alternative congestion pricing schemes in different zones that are affected, and proposing new pricing schemes in order to boost the transport users to those areas that are less congested. Okay, so we could say that yes, the pricing schemes could help on boosting the use of not that much congesting areas to the transport users. And now we move to the second, let's say, case study. That would be the adaptive traffic control and connected and autonomous vehicles. So here also we go directly to the example. There is an incident in the light of of mixed scenario circumstance. So the system detects a severe congestion in the ring road due to a vehicle breakdown. So the response plan will consider that the traffic flow are directed to alternative routes. Also, the traffic signals will be adapted in order to absorb that extra flow. And also the connected and autonomous vehicles will receive indications for going through alternative routes. So all this can be done dynamically. And now we move forward, also continuing with the second service, to the cooperative incident management. Well, the COP, the main objective is to provide to the different agents involved in the transport network in order to give an overall overview or a situational picture on which is the status of the transport network. So they will have a visual interface, very probably on top of a map, showing the scenario, in order they get all of them a common understanding of the situation. So here in this slide, you can see different examples. Well, first of all, you can see that also it's very much used not only, for example, for ITS services, but also in other domains such as security forces. So in the first one, you can see a screenshot showing on a map like different indicators, incidents and alerts, and these different agents could be, for example, traffic managers, transport operators, councils, could all of them access to this visualization map. Okay. So here, let's say that there are like some specific features that would be handled in this functionality. The first one would be the visualization of the current status and the expected status of the network, the situation. Also, which one would be the minimum network performance allowed, or let's say like the minimum interest for each of the agents involved, which is the minimum service that each agent need to deliver. Also, which are those conditions for designing the response plans, also according to the minimum service. And finally, the system would deliver the response plan with a set of actions for solving that incident. So continuing with the cooperative incident management, here we can see, let's say, an example. So in the light of an event, our response plan will be delivered based on the priorities and the minimum thresholds service levels identified by the different agents involved for solving the incident. So here we will focus on two different case studies. The first one will be the synchronization of transit and traffic. So here, for example, here the frequency of the buses is increased. So the traffic signals will be adapted in order to absorb this extra demand. And the next one will be the synchronization of on-demand and transit modes. Here there is an example that a demand responsive transport is covering a service for a train station. There is a disruption on that train station. So there is a coordination between let's say the train operator and also the demand responsive transport operator in order to inform, okay, this train station has been closed, so you need to deliver to your passengers to a different train station. Okay, so that coordination among the different transport modes. And now we move forward to the third service, that is the transport network optimization for transport authorities. Well, this service is more focused on supporting decision makers at a strategic and tactical level, for helping to produce different policies. So here we will study different hypothetical scenarios. Now we are under definition in the project, and we will consider different premises for identifying the response plans. We call it what if scenarios. So here are some examples. For example, what if the usage of autonomous vehicles is increased in the city center? Or, for example, if bike sharing is introduced in the city as an alternative choice. How all these situations would affect to the rest of transport services. Okay. This service will be designed in simulated mode under different scenarios. Okay, now we move forward on the overall concept. Well, the project.
Sorry, Larry, we are a bit running out of time now. Do you have many slides left?
Yeah, no, I can go through them. Yeah, in 1 minute. Okay, yeah,
Okay, thank you.
Yeah, it's good. Yeah. Okay, so here I'm not going to stop. This is the work package breakdown structure of the project. We are testing the solution in 4 cities, in Lisbon, Greater Manchester, Rennes, and Athens. For all of them, we have the transport operator involved in the project. Well, only in the case of Athens, that is a virtual living lab. Well, of course, the project is done in a consortium of different partners. We are 13 partners, academical partners, also ITS services providers, consulting companies, and the stakeholders, as I mentioned. And finally, this is the last slide, the timeline and milestones. We are now in month 10 of the project. We are on the first stage, and we are reaching the milestone of user needs and system requirements identification. And well, the next milestone will be focused on the definition and the system architecture and the development of the different modules, but that will happen in the 2023 year. Yeah, that's all from myself. Okay, thank you.
Okay, thank you so much, Larry, and thank you for speeding up the last part of the presentation. And as previously said, we will await with the Q&A session to the end of this webinar. So then I just give the stage to Marit Natvik from SINTEF, presenting the orchestra project. So please, Marit.
Yes, thank you, Runar. I will share my screen. It stopped. Everything stopped. Can you hear me?
I can hear you, but the screen is black.
Yes.
You're trying to share something.
Yes, I trying to share, but everything stopped up.
It's a rotating circle.
Yes. I tried to. Oh, I'm not able to interrupt it. Strange. Can you take over the sharing so that my sharing is interrupted and I can try again?
I can try.
Yeah.
For a moment. Now you can see. I didn't.
No, you can see. Yes, I see. Yeah. Okay, so it was just some delay in the system. So yes, thank you. I am Marit Natvik. I'm a senior scientist in SINTEF, and I'm also the technical leader of ORCHESTRA. So I will present our plans for ORCHESTRA project. That is about resilient orchestration of the traffic in the whole transport system. I will start with some pictures from the area around where I live. So this is the result from extreme weather conditions this winter. So one of the main roads were washed away. This is a more unpredicted situation where we had a landslide on the road to the airport, and at the same time we also had a signal failure on the railways. This is a more planned situation where there were construction work on the bridge last summer and in the middle of the tourist season, so it was long queues. People had to wait for 2 hours or even more. So the question is, how can such abnormal disruptions, as I have showed you, as well as more normal situations like congestions and incidents, be handled in a better and more resilient way than today? So ORCHESTRA is about the traffic management of the future. It's a Horizon 2020 project. It started in May last year and it will last till 2024. And it's about the multimodal and resilient traffic management during normal and abnormal situations. And by multimodal, we mean that we consider the whole transport system and how traffic can be managed in a coordinated way in the whole system, and not as today in a suboptimal way within just one mode or just one network. Resilience means that we will detect problems as early as possible, preferably even before they occur. And we will also try to prevent problems and reduce the negative effects of the problems. And after the problems, we will try to re-establish the normal situation as soon as possible. So we have two living labs, one in Norway that is in an industrial park, where goods are transported to and from the park through road and by sea. And the park has its own network, and it's a very dangerous environment, so the traffic has to be managed and monitored very carefully. The other living lab is the Malpensa airport in Milan in Italy, where the passengers that travel to the airport by rail and by road by means of different services. And there also is the flow of passengers within the airport itself. So we will test some of the solutions in these living labs, but it's very limited what you can test in living labs in a project like ORCHESTRA. So we will try to have more advanced solutions that are scaled up, and with more advanced solutions in simulations that extend the living labs. Today, the traffic management is carried out within silos. So the road traffic management don't talk with the rail, air, and sea traffic management. So the ORCHESTRA idea is that we will coordinate and synchronize the traffic management across the different modes and also across networks within the different modes. And we will also try to support those that are providing transport services, and preferably multimodal door-to-door transport services, so that they can plan and manage the transport chains in a much better way than today. We will also try to support those that are managing the individual transport operations. So we will support the fleet operators in a better way so that they also can plan. Hello? Do you see the screen?
I see the screen and hear you very well, Marit.
Okay, because
No
my
problem.
screen went black, so I don't know what happened, but I will continue. So
We are seeing a slide named the ORCHESTRA ID.
Yes. So we will also support the fleet operators. And we will also coordinate with the vehicles themselves. You see that we support the connected and automated vehicles. You can see that?
No, that slide is not visible for us.
Ah, sorry. I actually don't know what happened. My second screen went black. So I think I will. Okay, I will try to share my other screen. Sorry. I usually don't have problems like this.
Can you hear us, Marit? Can you hear me?
Can you hear me?
Yeah, now we hear you. The video was frozen.
Yes, I will share my. try to do it in another way. Can you see it now?
We can see a slide, yes, the orchestra ID.
Yes. Yes, so now I'm operating with just one screen. I hope that works. So in addition to support to the transport service provider and fleet operators, we will also support the vehicles and vessels themselves, and especially with the focus on support to connected and automated vehicles. You can see the next slide.
Yes, we can.
Yes,
Expected results.
Yes, then it's okay. So, the expected results is polycentric multimodal architecture. I will come back to more about that one. It's also technical tools that will support the traffic management, and also training models that will support the training of those that are carrying out the traffic management. And it's recommendations to decision makers about policy, about regulation, standardization, and such things. And it's organization models that support the flexibility that is needed in the organizational as well as the technical solutions with this type of resilient traffic management. And it's business-related models, more like value networks in this ecosystem that carry out the traffic management. And it's, of course, the evaluation results and lessons learned. And all these results will be supported by the living lab and simulations that I mentioned earlier. And it's also what we call the community of practitioners that are experts within relevant fields that are contributing by providing input, and also they are providing comments on intermediate results and such things. So now I will talk a bit more about the polycentric and multimodal architecture. The main intention of it is to support the common understanding of what this multimodal and resilient traffic management is. Because it's many new concepts, so it's not so easy to understand, so it has to be defined very well and in a holistic way. So it will define new concepts. It will also enlighten the solution from different perspectives, like the stakeholder types and roles involved, functionality needed, the processes that has to be carried out, and also very important, the interoperability and information sharing that is needed, and also the collaboration. So this architecture is not an architecture for an individual single system. It's what we call the reference architecture. It's architecture for a whole family of systems that support the implementation of systems that fit into a digital ecosystem for multimodal and resilient traffic management. So it's an architecture for a system of systems. And you can implement several systems according to this architecture, and they will fit together. So we are not focusing on the detailed functions of the systems, like user interface and such things. It's more about how they have to be implemented to be able to integrate and communicate with each other to fit into the ecosystem. So I will try to explain this ecosystem and what our focus in this ecosystem will be. So we have, for the transport part of the ecosystem, we have the transport user that need mobility or transport or passengers or goods. And we have the transport service provider providing transport services to this transport user. So they have to plan and follow up the multimodal transport chains. And we have fleet operators that manage the individual transport operations. So they have to manage the fleet resources, and they have to plan and follow up the individual operations. And of course, we also have the network user, the vehicles and vessels that are moving around in the transport network. So they accomplish the transport operation, but they also have to adapt and to the traffic regulation and to the traffic situation. In the traffic part of the ecosystem, we have multimodal and resilient traffic management that I will go into the details of later. And we have smart infrastructure management. And it all has to relate to the society and others like policy, regulation enforcement, emergency management, environmental protection. So these yellow parts are what we are focusing on, and especially we focus on the role of the traffic orchestrator, what that role has to accomplish and how it interacts with the rest of the ecosystem. So we have done an analysis of the motivations of the different stakeholders. So this is just a small extract of the motivations of the traffic orchestrator. And the reason why we did this is that this multimodal traffic management is a transition to something new, and we have to analyze what are the drivers and the benefits for the different stakeholders. So the traffic orchestrator will, among others, have drivers like better utilization of the network, avoid human errors, and better operation under abnormal conditions. The current situation with respect to this is that today it's difficult to affect the traffic volumes. They lack decision support, they lack collaboration across networks, and also they have to handle situation manually. And the goal will be to support, have better support for optimal traffic management, have decision support for resilient traffic management, and also better data sharing. And this is just a snapshot of a much larger diagram that have really analyzed the traffic orchestrator's motivations. And we have done similar things for the other roles as well. With respect to functionality, I focus on the multimodal and resilient traffic management.
Sorry, Marit, how many slides do you have left? We are a bit behind schedule here.
Yes, I will try to speed up. So
okay, thank you.
Yeah, yes. It's about to support situation awareness. It's about to support decision support and decision making, and it's the operative traffic orchestration. So we have to configure the zones where the traffic management will be carried out, conditions and measures. We have to carry out transport demand management and demand capacity balancing, and also very important to coordinate with other networks and modes, and also interact with the transport actors to the left in this diagram. So transport demand management is about making transport more sustainable. So we have to influence the traffic volumes and types. We have to influence efficiency, climate neutrality, inclusivity, and so on. And it's also the measures that we carried out. I have some examples in blue to the right here, are carried out in zones in the network and can be access control, priority, information dissemination, traffic calming measures, payment measures, and so on. And much of this can be automated. The other concept is the demand capacity balancing that have to come into place when there are imbalance between the volumes and the capacity, for example, due to some unforeseen or foreseen or planned situation. So the measure is to have to re-establish the balance. So it can be to communicate with individual network user. It can be to redefine the use of the infrastructure, open and close parts of the infrastructure. It can also be to use the transport demand management measures in a more dynamic way, and also to transfer transport to other modes and networks. So this can partly be automated, but also many of the measures have to be manually. So here are the partners in ORCHESTRA. It's coordinated by ITS Norway. So that's it. Thank you very much.
Thank you so much, Marit, and also for speeding up the last part of the presentation, so we're not too much behind schedule. So I just passed the stage on to Sasha Hogendorn Lamser. So please, I'm not sure about the pronunciation of your name, but
That's always a problem. Let's see, I think it should be in here. You see my screen, guys?
yes, but not in presentation mode. It's the other way around.
Why?
You see just current and next slide on the screen.
Oh, this is strange. That also has to do with the fact that I'm, oh, okay, I see how I can do it differently. No problem. Stop sharing. They gave me a new laptop and a marvelous one, but
If you go in the view that you just had,
now
if you
it
go back to the
should
same
be
view.
fine.
Oh, yeah,
No, it
there
looks
we go.
fine.
Yeah, sorry, needed to use the other screen. Let's speed up. My name is Sasha Hogendorn. I'm director of the Mobility Innovation Center at the TU Delft. I'm in the lucky position to coordinate this project together with my husband, Professor Serge Hogendorn, who is professor of smart urban mobility at Delft University of Technology. Instead of starting with transportation, why aren't we going to the next slide? Yeah. Instead of talking about transportation, travelers, mobility first, I want to take you towards natural phenomena. What you're looking at is a swarm of sparrows. They can make these beautiful organic forms in the sky. On the one hand, they don't collide into one another, but at the same time move in the direction that they want to move as a swarm. So the group of sparrows is fully self-organized based on a set of simple rules that they have inherently in their system. Something similar happens if you look at sheep. For most of the day, sheep are self-organized as well. Only, for example, at nighttime, when they need to be moved to a sheltered area, there will be a shepherd and probably one or two dogs that will give them a small incentive, a small push to go in the right direction. Afterwards, they self-organize going into the sheltered area. The last one, and I'm not sure if you've seen it, this was a movie that can be found on internet from Valentine's Day last year. What you're looking at again is sheep, and in this case, a farmer put food in the shape of a heart and let all of the sheep go. So normally they won't do this self-organized, but in this time, in this case, he used an incentive to let the sheep do this. So what you've seen in the three pictures is on the one hand full self-organization with some information put from the outside, and a situation where you really give incentives to, in this case, let the sheep make the form that you want them to make. What we've been looking at is what we call swarm intelligence, and the concept of swarm intelligence is the main paradigm that we're using in our project. And the reason for doing that is that you see that our mobility system is becoming more and more complex. There is increasing connectivity between people, between vehicles, between all types of elements within our traffic and mobility system. We have much more possibilities to intervene in the systems. We have multiple services offered, specifically all of the new shared services that are available. Even if we look at the Netherlands, we have increased demands for transport, and you also see this tendency of further individualization of people. So these are reasons to say, is the way that we're managing our traffic and mobility system currently the best way of doing it? At the same time, we want a system that is robust against unforeseen disturbances. In the past, we mainly looked at the larger incidents, but we have had the COVID pandemic. For example, in the southern part of the Netherlands and the adjacent areas in Belgium and Germany, last summer we had severe flooding. influencing the system. So we want a system, a traffic and transport system that is robust against these disturbances. Another problem that comes with the larger connectivity that we have is that data security and privacy become more and more important. And if you're able to use a decentralized concept, it might offer a solution to keep data security and privacy as good as possible by trying to use the data as locally and as closer to the different system components as possible. And the last reason that we're looking into swarm intelligence is the fact, at least in the Netherlands, but I think that holds for much more countries, is that these centralized management of systems becomes at a certain point infeasible. Systems are simply becoming too big and computational times too large. But on the other hand, you can also argue that from a human perspective, it's undesirable. If you're going towards a system optimum, will it in the end be profitable for everybody in the system? So these were for us the main reasons to look into the concept of swarm intelligence and to see how that can be applied within the traffic and mobility system. What are the key challenges that we're working on? The first question is, how do we design the interaction strategies between the different travelers, cars, traffic lights, all of the elements within the system, in the same way as how are the sparrows interacting with one another? So how can we define the way they operate towards one another in such a way that in the end, on a system level, we get efficient behavior? Other question and challenge that we have is, what is the maximum level of decentralization that's possible? Or if we look, in this case, at the sheep, how often should the shepherd intervene in that flock of sheep? And can we minimize that as much as possible? The other question, I just talked about privacy and security. What's the minimal amount of information that we need to exchange between the edge, so locally, and a cloud, and how can we minimize that? And in the end, what we want to do is to determine the effectiveness of this swarm intelligence approach for different applications at different levels. So on the one hand, looking at connected vehicles, at traffic management, at demand management, at service planning. So for all these different types of applications, see how we can apply that swarm intelligence paradigm. What's the project objective? In the end, we want a transition towards a seamless and sustainable, connected and autonomous mobility system, leading, of course, to all types of social objectives like improved livability, safety, resilience, efficiency on all urban scales. And we do that by trying to disentangle all of the system components. So you have monitoring, information precision, communication, control. On the one hand, to the greatest extent possible, but at the same time ensuring that there is sufficient cooperation and coordination by designing the system in a smart way. So that thinking about the rules, how to implement the swarm intelligence. The table might look a bit complex, but what you see on the left are the 4 main application domains that we're looking into. These application domains differ with respect to the time and spatial scale that we're looking at, whether or not we're looking at demand or supply, and the entities that we're considering. So if we look at the first line, the multi-class cooperative connected traffic, we're looking at local intersections. The time scale that we're looking at is seconds to minutes, and it's basically looking at the supply side, how to distribute the capacity to the different users of that intersection. And I will show later, we're looking in Bordeaux at a specific intersection where you have on the one hand cars, cyclists, pedestrians, and a tram line. Also, we're looking at cooperative multi-class distributed traffic management. Better said, we're looking at a network level, and with respect to time, we're looking at minutes to hours. In this case, again, we're looking at the supply side, but in this case, not on the level of an intersection, but to see how network capacity can be distributed between the different users. And the third one is distributed multimodal demand management. So focusing in this case on demand, using an auctioning concept. Again, looking at network level, but in this time, the time horizon is a bit further, hours to days, and we specifically focus in this case on the travelers. And for the last work package that we have related to a pilot that we're going to do with that is the fair cooperation schemes for urban mobility management. Again, looking at the network level, but even further ahead into weeks. And here we're looking at the operators of systems. So we look at service providers, local and regional authorities, public transport companies, companies that offer a new shared services, and looking specifically how they will interact with one another. What do we aim to achieve? We, on the one hand, want to come up with the theoretical foundation behind this swarm intelligence concept, and based on that, develop algorithms, implement that in our software platform, and in the end, apply that in 6 different pilots that we can use to assess the value of the concept in that case, and also demonstrate to a much broader group of users like road authorities, municipality, ICT companies, what the value of this concept in these different situations can be. At the same time, we will also want to show the impacts, the technical requirements and the costs, such that, for example, again, these road authorities or policymakers can make appropriate investment decisions. And the last step, again, related to what are you going to do locally and what are you going to do, for example, in the cloud, which information needs to be exchanged, how to use that distributed intelligence to keep the amount of data that's flowing from one place to another to a minimum. The 6 pilots, I found it very interesting to see what pilot locations you're looking into. We have 6 completely different ones. The first one is related to the first work package, related to a local intersection that we're looking into in Bordeaux in France, where we have real-time auctioning between the different participants that approach an intersection. The second pilot related to the next work package will be held in Utrecht, where we're looking at part of the network and see how we can distribute the capacity to, in this case, multimodal traffic. So cyclists, pedestrian, road traffic, but public transportation as well. Then we're going into Amsterdam related to our work package 4, where we're looking at mobility management through credit trading. That's we're going to look into a real part of the network in Amsterdam, but in the end, we're going to use serious gaming to see how travelers among one another will trade. We're not allowed in the Netherlands, and I think nowhere in Europe to have a trading mechanism in real life. So I think using the serious gaming, and we're aiming for approximately 5,000 to 8,000 people participating in these serious games to get a good idea how the choices that people make affect the network, in which case we can ask them again to participate and make their choices. Then we will have a pilot in Glivana in Greece, close to Athens, where we're going to look in real life to different types of bus services, from smaller buses that might only have 8 people in them into regular buses that are much bigger. And we're going to use an app that people can use to select the different services that they want to use. So that's related to work package 5. Then we have 2 additional pilots, one in Athens and one in on the highway between Barcelona and Girona. So on the one hand, looking at urban mobility, and on the other hand, looking at interurban mobility. And those two pilots are simulation pilots, and they are meant to combine everything we learned and we developed in the work packages 2 to 5 and what we learned from the other 4 pilots. A quick overview of the project.
Sasha, do you have many slides left? We are still a bit behind schedule.
Just to, and I can say that the structure of the project are more or less showed, where our first work package is really about the concept, the theory behind swarm intelligence. I already mentioned the work packages in green 2 to 5, where we use swarm intelligence to develop a theory and algorithms for the different applications. You have the pilots, we have our platform in which we implement all of the algorithms that we developed. And finally, we have the assessment, and you have a lot of feedback loops through the project that make it difficult to coordinate the project. But on the other hand, I think it's very valuable to get all this feedback in the project. And then my last slide is just to mention, most people started with it, but it's so nicely related to the work packages. So ETH and BIU from Israel are looking at the generic concept of swarm intelligence. The other academic partners from Switzerland, Delft, Greece and France are looking into the work packages 2 and 5. Then we have a number of industry partners looking specifically at the technology development and the platform that we're using. We have a lot of different partners that are looking into the pilots that we're doing. And finally, Siemens, AMS and Polis are looking towards the business development and look ahead how this can be used by a much larger group of people. And then I will finish with telling you that we have our website. I assume you have it as well, but visit it if you want to have more information about our project. Thank you.
Thank you so much, Sasha. We have one more presentation for today, and that is about the Frontier project. So please, Panos.
Yes, hi, Runar. Can you hear me okay?
We hear you well.
Okay, let me share my screen. Can you see my screen okay?
Yes, it looks good.
Okay,
Yes.
Thank you. So hello everyone from my side as well. My name is Panos Georgiakis and I'm the scientific and technical coordinator of the Frontier project. So I have prepared a presentation and I have split the presentation into sort of 2 parts. So the first part is just a brief introduction on the project, and I'm just going to go through the main objectives, the concept and the pilots. And also the second part of the presentation is the some results based on some workshops and we have done to try to elicit stakeholder requirements, again in the scope of the project, but also in network and traffic management in general.
So sounds great, Panos, but I hope we can keep it quite brief so we have
I'll
time for a couple of questions. We need to stop 11:30 sharp, so thank you.
Yes, okay, Runar. I'll go quickly through the project and then try to So the project, as the other sister projects, I think we are on one of the earliest ones. We started about just over a year ago, 19 partners, and you know the size in terms of the budget and duration is very similar to the other projects. In Frontier, we have a concept where we are actually looking to develop a layer architecture of systems and services to support the sort of coordinated network management. So we split the objectives based on this sort of concept and approach. So we have an objective which is related to you know, getting the requirements for network management and try to design this sort of scalable architecture. Then we have a layer which is related to the data collection processing, which is the observed layer in our sort of concept. And the idea here is to have the necessary interfaces to real and historical data sources, try to get all this data into the platform and sort of harmonize this data. to allow the operation of the services to the layer above, which is the orient layer. And this is where we have also the sort of data processing side of things and try to generate some intelligence from this data processing. We have two elements on this. We have the sort of data-driven algorithms, which is mainly machine learning and AI algorithms, but also have the simulation framework. So we use this to in combination to do services like incident detection, traffic forecasting, response plan assessment, etc. So once this sort of data has been processed and has been sort of enriched, then we use this data for some decision making, and the decision making is actually basically related to network management. So I'm going to show you this concept of operations that we have come up with during this first year of the project, and you'll see these sort of decisions in a bit more detail there. Once the decision is made, then we need to have we have the action, and this layer basically we sort of deploy a particular response plan to upkeep the resilience of the network, and then try to monitor this response plan, see how well it affects the network, and also try to learn from that. So this sort of observe, orient, decide, and act is sort of the underpinning architecture of our approach. And then we have a number of sort of vertical aspects related to business models, arbitration models, and organizational structures assessments. And these are sort of required to allow this sort of multi-stakeholder collaboration. And we have a number of demonstration pilots, and I'm going to just talk about this in a bit more later. And of course, the dissemination activities. In terms of the network management approach, we have this sort of autonomous network and management engine at the heart of the system, and the main responsibility of this engine is really to generate different response plans based on the situation of the network. And once response plans have been generated, then we can assess those response plans based on data-driven algorithms, but also based on simulations. We have a number of different algorithms and models that we'll be developing to sort of look at the supply and demand, and then try to incorporate those two as part of the response plan. And of course, we need to develop a number of internal interfaces for all these different components to actually talk to each other. We have external systems that we need to integrate to our platform, and this could be from ITS systems, cards, etc. And of course, we need to develop the interfaces to actually communicate with these external systems. So this is a very quick snapshot of the sort of architecture that we are actually developing as part of the project, and the solution we're actually developing as part of the project. In terms of the pilots, we have pilots in 3 areas. So the first one is Oxfordshire in the UK, and this pilot is mainly focused on calves. So we're going to have some real trials with calves in a test bed and try to sort of achieve this communication between autonomous vehicles and a traffic control center, or an emulated traffic control center, which is something that is not actually happening at the moment. So we're going to look at all these sort of interactions and the technical challenges there. Then we have a pilot in Athens, where we have a corridor from the airport to the center of Athens. And in this one in particular, we are looking at the multi-stakeholder collaboration. So we're looking at how we can actually develop response plans that have been agreed by different stakeholders, and basically try to keep the resilience of the network if an event takes place at any service, either being on the road, a public transport service, etc. And the last pilot is at Adverb, and in that in particular, it's more geared towards freight transport. And here we are looking at 2 corridors, and a waterways corridor and a road corridor, and we can see how we can sort of again do some joint response plan generation to try to sort of shift some of the freight traffic from the road corridor to the waterway corridor where this is applicable. And in all pilots, we have this sort of simulation as well, environment where we can actually do planning for events, special events or large events, again in a sort of multi-stakeholder way, but also have some new simulation models for autonomous vehicles, so we can see how the progressive, let's say, integration of autonomous vehicles into traffic streams can benefit, let's say, the overall network. So again, these are a very quick introduction to the project. So now I'm going to move on to the presentation about the stakeholders' requirements. So we did a couple of workshops the last few months to gather stakeholder requirements and looking at the different stakeholders, and we try to group those into the infrastructure operators, which are the principal, let's say, operators responsible for the network management. Then we have the transport mode operators. We have a layer higher up, the network performance and analysis, policymakers and decision makers, and then we have the sort of business side from the logistics and technology providers. So we try to sort of capture the different user requirements for stakeholder requirements for all these different groups. So we did two actually webinars. The first one was mainly the participants of the first one were mainly internal to the projects. We have a number of network management and public transport managers in the consortium. And the second one was the second one had participants from, let's say, wider stakeholder network external to the project. So we had 21 external stakeholders in the second one, coming from different backgrounds. Focusing mainly, again, you can see that about 40% of them are motorway or road operations or public transport operators. And some results from this sort of webinar, the second one with external stakeholders. In terms of the key priorities for the future mobility, we found out that, you know, promotion of shared mobility is one of the key priorities, together with, you know, safety aspects and also multi-agency coordination. Which again is something that those three areas are quite prominent at the moment at the EU level when it comes to mobility. For us, it's because again we have this sort of major element of the project looking at the multi-stakeholder collaboration. We try to find out if there is an existing collaboration between stakeholders and how is that achieved at the moment, if it's like an official collaboration or an unofficial way. And you can see there's probably a 33% roughly split among the three answers. So there's 37%, there's no collaboration at the moment between the different stakeholders, and another 31% yes under an official contract agreement and yes without an official contract agreement. And then we try to delve a bit more about the reasons for that. And it could be because maybe there's no processes in place, maybe there's no regulatory framework to support this kind of collaboration. Some cases, unofficial collaboration is enough to achieve the necessary operations, etc. And then we try to present the concept of operations that we have and try to identify how that then looks and how that may help, let's say, in the network management. And this is a very sort of condensed version of this concept of operation, and split into three main stages. The first one is the incident detection and the confirmation of the incident. So all stakeholders are happy that yes, an incident is actually taking place at the moment. The second stage is the response plan generation. And this is something that has to be done in a collaborative way. So there may be different response plans, and then all the different actors must agree to a single response plan. And then once this response plan has been agreed, then is the execution of this plan. And following the execution, we monitor the performance. And if necessary, we need to go back at the beginning and start this process again. If everything goes well, then we can sort of declare the event as finished and resolved. And we try to have this sort of concept of operations for this ADME solution that we develop. And we did this based on the existing concept of operations that different organizations have, because we try to make sure that whatever we propose doesn't differ much from what they actually are familiar with. So based on that, we try to find out, you know, how likely is to adopt different functionalities of the ADME solution. And here you can see there's a lot of positive, let's say, reactions in terms of data sharing. So there's no problem of, let's say, stakeholders sharing data, and also, you know, try to come up with a response plan plan in a collaborative way. But what we found out is that it may be difficult for some actors to agree on a response plan that may conflict their interests, which sort of makes sense. And this is one of the areas that we're going to try to address as part of the project. The usefulness of the solution, and again, I think more or less they thought that all these sort of proposals that we have will be useful for their operations in terms of, prediction of the network, utilization of simulations, collaborative development of response plan, etc. So there's sort of quite balanced here acceptance of the usefulness. Similarly, in terms of the functionality of the solution we're developing in terms of network management, we can see here that quite important, or the one of the highest importance is the one about monitoring the execution of the response plan and see how the event develops. So again, this is something that we have incorporated into our solution with a sort of a big feedback mechanism. And again, the rest have some sort of equal bearing in terms of importance. Of interest also, I have a couple of more slides, Runar, and I'm finishing. So the potential barriers, again, it was quite important for us to see that what are the potential barriers for the current, let's say, situation, but also the future network management solutions. And we try to split those into technological, legal, and business barriers. And as you can see, there's the most important ones, especially from the technology point of view, was the lack of standardization in terms of the different mobility service providers and the data they use. And again, this is something that through the project we have seen from the data sources that we have available, and we have tried to provide some sort of novel way of harmonizing this data through some data graphs and try to allow this sort of integration of data. From the legal side, at the moment, there is no regulatory frameworks in place to support this multi-stakeholder collaboration. So again, this is something that needs to look after. And the business side, I think the least, let's say, important or disruptive in terms of barriers. Again, these are, by the way, this will be actually reported in one of our public deliverables. So hopefully you'll have access to that. And of course, the presentation, I can make this available as well. And a couple of last slide for the future, what are the priority objectives for the future. And again, the most important one is the resilience of the network and operations and cooperation among the different stakeholders. So again, we can see that things that we have sort of tried to solve today are also priorities for the future. And the last one is about any functionalities that a future network management system must have. And again, the most popular one here is the easiness for the operator to be able to use the system, and also provision of data back to the involved actors. And again, this is something that there's a lot of discussions today about data, who has the governance over the data, et cetera, et cetera. So you can see this is something that also an issue that needs to be sort of looked at also in the future. And that's it. So thanks for your attention, and I'll be happy to answer any questions that you may have.
Okay, thank you so much, Panos. I know we have 1.5 minutes left for questions. Sorry about this. Some of it was due to some technical problems for sure. But I assume that all of the presenters are willing to answer any questions offline after this webinar. So to end this on time, I want to thank all the presenters and especially the keynote speaker from Sorco. Thank you so much. And I think we will hear more from the 4Front cluster projects. And if you are in Lyon during the Connecting Europe days, please visit or stand there. And we can speak more about the different projects and the expected results.
Perfect.
So
thank you very much for the invitation, and thank you for the interesting other talks.
Thank you all for participating and have a nice day.
Thank you. Bye-bye.
Thank you. Bye, everyone.
Okay, thank
Bye-bye.
you.
Thank you.
Thank you. Bye.